In this video instruction, I want to talk about a form of reduced inrush motor starting called Y delta. Inrush current is the initial current draw of the motor when it's first powered, and typically the inrush current is 300 to 800% of the full load amperage of the motor when you start the motor across the line with full voltage right from the start. If you use the Y delta starting method, that reduces the inrush current by 30 to 40%. You may hear the term reduced voltage, and you'll see here why it's sometimes termed reduced voltage motor starting. When you start the motor in the Y configuration and you have 460 volts in this example from L1 to L2, and you would also have 460 from L1 to L3, L2 to L3, you only put 230 volts or half the voltage across each inductor winding inside the motor. You start the motor in that configuration, which is reduced voltage on the winding, and then you switch it to the delta configuration here, where you have full voltage on each winding, 460 volts. A typical Y delta starter package would look something like this. There's three contactors. I know there's a lot here that's kind of confusing. This is from a York chiller diagram. I kind of whited out most of the stuff to make it look a little bit easier to understand, I hope. You see up here you've got your three-phase power coming in. It feeds the top of these two contactors, and this contactor here is called a shorting contactor, and you'll see how that works. Let's put some numbers to the motor leads here in our configuration. This would be a typical 6-lead motor. Now this would not be a dual voltage motor. I'll get to that at the end, how you would do what's called a 12-lead Y delta motor that would be dual voltage. This is a single voltage motor, has leads 1 and 4, 2 and 5, 3 and 6, and like most Y connected motors, you would just go around clockwise 1, 2, 3, and then 4, 5, 6. When you switch it to the delta configuration, you're taking this winding here, 1 and 4, here's your 2 and 5, here's your 3 and 6, and you're connecting it in the delta configuration. When you do the Y start, you put power on terminals 1, 2, and 3, and you do not power 4, 5, and 6, but instead you short 4, 5, and 6 together, and that gives you this common junction here, power on 1, 2, 3, and that's how you start the motor. The power across each winding is half of the full voltage, so it starts and it runs. When you switch it to the delta configuration, you put full voltage on both sets of windings, 1, 2, 3, 4, 5, 6, and you open this shorting contactor. Of course, you never would want these two contactors to pull in at the same time, the shorting contactor and the run contactor, because if they did, you would have a dead short, blow the fuses. So there's a mechanical interlock here, and that means that there's going to be a certain period of time between when you start pulling this contactor, close your shorting contactor to do your Y configuration. There's going to be a short period of time when you have to stop and restart the motor, and that's called the transition period, and I'll talk a little bit more about that. But once you transition from the Y configuration to the delta configuration, whether it's based on amperage or based on time, the motor comes up to full voltage. If you do have a 12-lead motor, dual voltage Y start delta run motor, this is what you'll typically see for the connection diagram, and you're thinking, well, I can only have 6 leads. How do I use a 12-lead motor and only end up with 6 leads to do the Y delta starting? Well, in this configuration here, your combination of 6 and 12, 4 and 10, 5 and 11 would actually be your 6, 4, and 5. Your combination 1, 7, 2, 8, 3, 9 would become your 1, 2, and 3. So that would be your 6 leads. When you started in the run configuration, you can see that 6 and 12 are still connected to each other, 1 and 7 are still connected to each other. So that's how you do it with their low voltage. For the high voltage, if you're doing Y delta with the 12-lead motor on high voltage, you would internally connect the 4 and 7, 8 and 5, 9 and 6 together. Those would stay that way, and your 6 leads that would be coming out would be your 1, 2, 3, and then this would actually be your 6, 4, 5, 12, is 6, 10 is 4, and 11 is 5. And then when you do the shorting of 4, 5, and 6 for the Y configuration, you power 1, 2, 3. When you put it into the run configuration, you power 1, 2, 3, and then 12, 10, 11. The term you may hear is open transition versus closed transition, and this is a whole another topic in itself. But think this just to a quick explanation. Open transition means that the current draw will stop during the transition from Y to delta. So you have it start in the Y configuration, you completely remove the power, and then you re-energize the two contactors to put full voltage on the windings. That goes, put it in the delta configuration, and it goes to full voltage. That current, that draw of current when it just stops and restarts can cause problems with the power system in your in a building. So they have what's called closed transition, that the current draw continues by way of a fourth contactor and these power resistors during the transition, so that you still maintain some current draw when it does the transition from Y to delta. And if you ever see these great big resistors, these are high wattage, low resistance resistors. This is just for that short period of time when you transition from the Y to the delta, and this through the motor windings keeps a load on the power system as it transitions.